There is a healthy competitive scene around the up to 10-player competitive arcade game Killer Queen. And now the game's creators are coming to THEGA Meet Developers Conference next month to share how they pulled it off. So come out and catch Funktronic Club's producer, Alan Daly and GDC community, MANAGEMENTSUMMITTALK on how Killer Queen built an esports scene on an indie budget, in which he will show you how he approaches building community by aggressively engaging with its community and enabling its core fans to express themselves, from community outreach and participation, to how merchandise is handled, to even game design and system features. A variety of different aspects arcade successfully, and not so successfully, help Petal foster a competitive national scene for an indie game. This is a great talk to see if you love Killer Queen. But it's also packed with useful takeaways for developers who are creating competitive games and want to build a community around them, as well as community managers who are looking at ways to build communities around competitive games. Do not miss out. Find more details on this talk and many more over on THEGDC 2019 session scheduler. There you can begin to lay out your GDC 2019, which takes place March 18th through the 22nd at the newly renovated Moscone Center in San Francisco. Bring your team to GDC, register a group of 10 or more and save 10% on conference passes. Learn more. For more details on GDC 2019, visit the show's official website, or subscribe to regular updates via Facebook, Twitter, OS. Gamasutra and GDC are sibling organizations under parent company Informa. The chief executive officers of two major video game companies have found their way onto SUSO's 2019 report on the 100 most overpaid CEOs. The report that uses pay data to call out pay disparities in publicly traded American companies. Both Electronic Arts, Andrew Wilson and Activision Blizzard's Bobby Kotick have earned spots on this year's list along with the likes of Walt Disney's Bob Iger, Netflix's Reed Hastings, and 96 other high-earning execs. This all comes just a week after Activision Blizzard announced that it would lay off an estimated 800 employees following the close of a record year. SUSO takes more than a CEO's yearly earnings into account when ranking its list, something detailed in full in the full report. In short, the organization looks at factors like total shareholder return and votes against the CEO pay packages to calculate the chief exec's earning in excess. The methods for calculating that exact excess can be found in appendix in the full report as well. Following that methodology, the group clocked Activision Blizzard CEO Bobby Kotick as number 45 on that ranked list of the most overpaid CEOs. By SUSO's data, Kotick is paid $28. 375, an excess of $12.
835
277 by the organization's estimates. The ratio of Kotick's pay compared to median worker pay at Activision Blizzard is 301. The median pay ratio for SP 500 companies is 142. While the median pay ratio for the 100 members of SUSO's list is 300. Electronic Arts, Andrew Wilson, meanwhile, is ranked a bit lower on the list, as number 98. His yearly take is $35.
728
764, an estimated excess of $19.
673
861 as determined by the report. a paycheck that was supported by 97% of shareholders' votes. Though median pay ratio was not used as a metric for ranking those high-earning CEOs, the difference between Wilson's own pay and that of the median Electronic Arts employer is greater than Context's. As Wilson records that ratio as 371. 1. The gap between median worker pay and CEO pay has ballooned in just the past several decades, as explained in the following quote captured by Axios. If you look at the pay of top CEOs relative to workers, that ratio in the 1950s was 20-1, was about 30-1 by the late 70s, and by the mid-1990s it was 120-1, said Robert Reich, former Labor Secretary for President Bill Clinton, during a recent call with Axios and other reporters. When I was working in the White House, that was a cause of real concern. That ratio seemed appalling to most people. Now it's 300-1. China announced that it approved dating game releases in late December, signaling the first wave of media authorized by the Online Games Ethics Committee. However, the list of approved titles does not seem to include any releases from Chinese tech giant Tencent. This report comes a few weeks after Chinese regulators began reviewing games submitted under license consideration in China, moving forward to the licensing freeze that had halted game approvals for the majority of 2018. As reported by Reuters, these approved titles, listed on the website of the State Administration of Press, Publication, Radio, Film and Television, did not include games from industrial leader Tencent. The freeze has negatively impacted the company, and despite mobile revenue on the rise, the company has lost more than $200 billion of its overall value. Tencent began testing facial recognition to verify player identities, and even restrict playtime in an attempt to appease the Online Games Ethics Committee, which was created to address concerns from Chinese officials who fear that video games are sparking addiction and impacting the productivity of the country's youth. Regulators have also prevented Tencent from monetizing popular games that were already on the market in China, including Fortnite and PlayerUnknown's Battlegrounds. This was originally published here. Are you looking for inverse dynamics in Unity, or Unity's physics engine? Physics. It does not exist as far as I can tell, but it does exist for other physics engines, such as Bullet and possibly Open Dynamics engine. Luckily, inverse dynamics is not too hard to implement in Unity. Unity does have an inverse kinematics feature, but that only helps you with kinematic motion, and not with physical-based motion. You do not want your humanoid character to just move. You also want him to move realistically. That's where inverse dynamics comes in. Before we dive into the implementation details, you can find an overview of inverse dynamics, an overview of inverse kinematics, in this article. First, we will go over an abstract algorithm, so you understand the high-level procedures to implement the inverse dynamics algorithm. Then, we will go over the actual equations you need to implement the algorithm. Finally, we will go over the base cases necessary for this recursive algorithm. The ultimate output of inverse dynamics are the forces and torques of the rigid body required to make a movement, with the inputs being the orientations, angular velocity, and angular acceleration at each joint. One algorithm to achieve this output requires a forward iteration from the root link to the final output link, and then a backward iteration from that final output link back to the root link. It is called the recursive Newton-Euler algorithm, RNE. It was developed by a worker and pole in 1980, and it continues to be championed to this day by other researchers, such as Featherstone and Murtick. The first part iterates from the root limb to the final limb. For each limb, it computes the angular velocity and angular acceleration of the limb. The computation for the angular velocity and angular acceleration of each limb is based on the angular velocity and angular acceleration from its inboard navel limb. For each limb, it computes the linear acceleration at the inboard joint. Computing the linear acceleration at the joint is based on the angular velocity and linear velocity from its inboard navel limb. This process of computing angular and linear velocities accelerations for each limb, from the root limb to a final limb, is called velocity acceleration propagation. This is because each velocity acceleration is based on the velocity acceleration from the neighboring inboard limb. In other words, the previous limb. The rest of the computations for each limb are based on the limb's own angular velocity, angular acceleration,